Hello everyone, welcome back to another GIS mathematics lecture video. And in this lecture video I want to talk about converting from polar coordinates to Cartesian coordinates. Alright, so this is sort of the opposite of what we did in the previous video. And to show that graphically, right, we're going from coordinates with r and a theta to coordinates that have an x and a y. Okay. And just like last time, I think it's best to do this with an example. So this is our example point right here. And what I want to do here is quickly, again, just for the sake of repetition, figure out what the polar coordinates are at this point. Well, first, we're going to look for theta, and we're going to see that it's on the 60-degree line. So I'm going to draw this line right here, just to sort of show that we are on the 60-degree line. And so this is going to be 60 degrees for theta. And then the distance, right? So this solid line right here, this is 4. We're up 1. It's going to be a distance of 5. Right, so our theta here is going to be 5, 60 degrees. Okay? So, what is this going to be in terms of x and y? And I think just like the last time, it's best to think about it in terms of a right triangle. So we already have one side, right? That's this. And then we can draw a dotted line down here. Okay. So what I want to think about is what we actually have been given. This right here, right? This length. That length, that's our r. So that's our 5. We also have been given, right, this angle right here. Right, this is our theta, which is going to be 60. Right, these are the pieces of information that we've already been given. Now, if we think about it in terms of this triangle, right, what we want is this distance right here. Right, this is going to be our x. Okay, and then this distance right here, right, this is going to be our y. Okay. So, if we think about what this distance is going to be here, right, y is the same thing as the opposite. So let's just make some quick notes here, right? In this case, so this is relative to theta. Which we were given, right? Relative to the theta which we were given, right? R, which is our the distance that we were given in our original polar coordinates, right? This is the hypotenuse. Right? Hopefully you can see that. Y, right, again, relative to our theta here is going to be our opposite. And then x, again, relative to theta is going to be our adjacent. So I've just sort of laid out, right, relative to this angle, opposite, adjacent, hypotenuse. Okay? So hopefully that makes sense. So, again, relative to theta, right, we know that to get y, right, we would use opposite, which is what we want to find, over, we're given the hypotenuse. Right? So if you think back to SO, CA, TOA, right? SOCA is opposite over hypotenuse. So we know that the sine of theta is going to be equal to the opposite over the hypotenuse. So we know that the sine of theta is going to be equal to x over r. Let me slide down just a little bit here. Okay, right? So let's go ahead and look at this relative to our actual equation here. So we now can say that the sine, so again, if we rearrange this, let's rearrange this first, right? We know that our x coordinate is going to be equal to r sine theta, right? So going back to our example here, right, our x coordinate is going to be equal to r, which is going to be 5. Let me pull in here, right? R is going to be equal to 5, right? That's our r, times the sine of, in this case, our theta here is 60 degrees. Be consistent in our stuff here. All right. So our x is going to be 5 times the sine of 60 degrees. So if we pull up our handy dandy calculator here, we hit delete. If we type in 60, make sure that we're in degree mode. Trigonometry sine. Our sine of 60 degrees is 0.866, etc. Then we're going to multiply that by 5. It's going to give us 4.33 approximately. So we now know that our x value is going to be equal to approximately 4.33. Okay. Hopefully that makes sense. Let's go ahead and scroll back up. Ooh, too far up. Let's take a look at our y. Okay. So our y relative. Oops. I actually made a mistake. We just did calculate y because y is the opposite. So this should all be y. I am so sorry. This should all be for y. So let's talk about x, right? X relative to theta is adjacent. So if we wanted to find x, right, our cosine of theta, right, is going to be equal to adjacent over hypotenuse. Okay, so now we're going to bring in x, right? Because we know that our cosine of theta is going to be equal to x, which is our adjacent, over hypotenuse, which is our r. Isolating for x, right, we get x equals r cosine of theta, right? So all I did was rearrange this equation just like before. So now we have the x value is always going to be equal to r times the cosine of theta. So let's think for a second about what that means. Well, if we use our actual values here, right, we have x is going to be equal to, right, our r, which is this distance here, right, from our original equation is still 5. Right, now we're using cosine instead of sine. Our angle, right, is still going to be that 60 degrees that we were given from the previous. Okay, equals. Let's go ahead and pull up our calculator again. Let's clear the previous work that we did. So this time we're going to type in 60. Again, making sure we're still in degrees. Make sure we're still in degrees. Trigonometry, we're going to hit the cosine. So the cosine of 60 degrees is 0.5 times 5 is 2.5. So now our x in this case is going to be 2.5. So to answer, scroll back up a little bit to answer our original question here, right? Our x and our y is going to be 2.5 for the x and 4.33 for the y. So hopefully that made sense. If you have any questions, pause the video, go back, rewatch the part you're confused about. And as always, please reach out. Thank you.